All right, good morning, everybody. So today we are moving into our brake systems again. We're going a little bit more detail this time. This is going to be 6.4 assist hydraulic brakes, hydraulic system checklist right here. So we got number one. It says identify poor stopping, premature wear, pulling, dragging, balance, or pedal feel problems caused by the hydraulic system. Determine needed action. Okay, so that's number one. So what we got here is I got a little list of things. What causes poor stopping? So poor stopping. First off, we want to make sure we check our fluid level on our brake reservoir. So if our fluid level is good, that's a good thing. If it's low, then we might be pushing air into the lines. And when you have air in the lines, you can compress air. You can't compress a liquid, so the liquid makes it so the brakes will apply. But if you have air in the lines, then the air compresses and then the fluid doesn't move to activate the calipers or the wheel cylinders. So check your fluid level. Also, the vacuum booster on hydraulic systems, they either have a vacuum booster or a hydro booster, which runs off the power steering pump, or a hydraulic pump of some sort. The big equipment will have a hydro boost. So you're going to check your boost. Is there a problem with the boost? Is the power steering fluid low? Because if you have low power steering fluid, then your hydro boost isn't going to be boosting your brakes. So you have to check your power steering fluid and make sure that's working. Make sure your pump is creating pressure and things like that. Also, you're going to check your vacuum line on a vacuum booster. So where that vacuum line goes in, and there's a few checks that we did before on our 4.14 brake inspection that you can test that vacuum booster. And I think I got a video of that as well. The next one is master cylinder defect. So in the master cylinder, there could be a defect. There could be a seal that's not sealing, and then the pressure is not being created when you push on it with your foot. And so there's an internal problem with the master cylinder. Also, we can have system fluid leaks, and so you're just going to take a quick look at your system and see if there's any leaks. Is it dry? Does it have any kind of wetness on it? If it does, then we have a leak, and that will cause poor braking in hydraulic systems. And then I'm going to check out we're going to raise it up, and we're going to do the rest of this inspection here. Okay, so here's some other things that cause poor stopping. We can have worn brake pads. If the brake pads are wore out and they're down to metal, that'll make it so it's harder to stop. We can also have a failed caliper, which is right here. This caliper has hydraulic fluid in it. If they leak out, or if the caliper piston's binding or something like that, it can also prevent from being able to stop. We also have wheel cylinders in the back here. So the wheel cylinders here are also have fluid in them, and if they fail, either the fluid leaks out, then the brakes won't apply anymore, or if there's some restriction in the line or something. Sometimes you get some rust or something that'll get plugged in there, plugged up in the line. Also, these can be inspected. You want to make sure you check them for leaks under the boots. So these boots here peel back, and you can see inside there if there's any kind of fluid or not, and that one looks pretty dry. If you catch them before they leak all the way out, you can replace them before you ruin the brake shoes. If you get brake fluid all over your brake shoes because of this leak, then you got to replace the brake shoes because they don't stop as well. And also when they get hot, they can catch fire as well because of the oil. Okay, there are some other things that can cause poor stopping. I'm going to lower this back down, and we're going to look at the portioning valve, the metering valve, and the combination valve. Okay, so the next parts of the vehicle that can cause poor stopping or bad stopping, hard stopping, is what I was saying was a proportioning valve or a metering valve, and there's also a combination valve. So on vehicles these days, they combined all those together in the same unit, and a lot of times it's in the master cylinder. So for an example, the proportioning valve is in the master cylinder, but also the metering valve as well. So it makes sure that it will apply the brakes in the rear before it applies the brakes in the front. And that's called the proportioning valve. What happens is we have about 70% of our braking goes on the front About 30% goes on the rear. And so what we have to do is make sure that happens, because most of the weight is in the front. When you hit the brakes, the vehicle will stop and push all the weight towards the front of the vehicle. And the brakes need to apply harder in the front than they do in the rear, because the back end kind of lifts up. That needs to be that's what your proportioning valve does. But there's a problem with this. If I apply my front brakes first, I end up skidding because the back brakes aren't doing their job yet. So it takes a while for that hydraulic pressure to go to the back of the vehicle to apply those rear brakes. And also, because they're drum brakes, they apply slower as well. So if I don't apply my rear brakes first, then I'm going to skid with my front brakes. So what they do is they have a metering valve. And what the metering valve does is it makes that pressure go to the rear brakes first. The rear brakes begin to apply. Once they start to apply, then the pressure builds up and it lets that metering valve turn the pressure on to the front brakes. So we apply the rear brakes first, the front brakes get applied after that, then we can do our 70-30 split with our braking portions there. And that is what the metering and the proportioning valve do. Now there is also a pressure differential valve, which in here you can see this switch right here. That is a switch with a wire sensor on it, basically, and that tells you when there's a problem with your proportioning valve or your metering valve. It senses when that isn't working right, and that will turn on your brake light in your dash. So that needs to be tested as well. Okay, our next part of number 1 is we're going to talk about some premature wear. What causes premature wear? I got a list here. And the first one is a stuck caliper. So if I have a stuck brake caliper right here, that brake caliper has a piston. And if it gets stuck, what's going to happen is it will apply the brake pads while you're driving down the road, and it wears them out really fast. They can also get stuck on the slides. Right here, there's some slides that allows this caliper to move back and forth this way. If that's stuck, it will wear one pad out faster than the other pad. And so that'll also cause premature wear as well. We also have in the back, we have the brake drum. There's hardware. So, and what that means is all these like springs and these retainers and things that are back here in a drum brake system, that's called hardware. And if those come off, then what happens is the brake drum or the brake shoes will actually hit up against or lean up against the brake drum as it's going down the road. And so there's nothing holding them off the brake drum. And so that'll cause premature wear as well. So the hardware has to be in good condition and functioning in brake drums. Master cylinder problem. You can also have a problem with your master cylinder. And this will cause premature wear. I've seen on some Chevy S10s where the master cylinder is constantly applying the brakes. It won't release the brakes for some reason. I've seen it so bad where you couldn't drive the vehicle, it wouldn't move. I have a hunch that most of those were caused by contaminated brake fluid. So if you have any kind of oil other than brake fluid in your brake reservoir, it ruins the rubber seals and it can cause all kinds of problems and wear problems on your brake pads. So those are some of the things for premature wear. And then I'll just, for pulling and dragging, those are basically the same things. So right here where it says pulling and dragging, that's going to be 3 of the basic same things we just talked about: calipers and wheel cylinders, and a bad master cylinder or contaminated fluid. And those are going to cause dragging. Once in a while, you'll get a rock wedged into the caliper right here, or behind the backing plate or something like that, and that causes some drag, and it also makes a horrible noise. You want to be careful with that. If stuck in calipers, you'll get a pull when you go to stop, because one brake is working better than the other. It'll cause the steering to go to one side. When you hit the brake, it'll make the car steer or veer to one side. And again, on any kind of diagnosis, if you guys have problems, you're trying to find out any problems caused by the hydraulic system, determine needed action. So what you got to do is basically you got to do an inspection. You're going to inspect those things we just talked about, and then a road test. You always want to do your inspection first, because if you don't do your inspection and it's unsafe to drive, you can get an accident. So you want to do your inspection first and make sure the brakes are okay to drive with. Then you go out and drive it and make sure you can find out what the problem is. Okay, on the next one here, number 3, we're going to inspect, number 2, inspect and test master cylinder for internal or external leaks and damage, determine needed action. So external leaks are pretty easy. You just kind of look at the master cylinder, see if there's any leaks. Sometimes the master cylinder will leak into the brake booster. So what happens is where it bolts onto the brake booster, the leak comes back from the seal where it bolts in there, and the fluid will leak into the brake booster. You may not see the leak, but there could be a leak in there. And so sometimes it's necessary to remove the brake booster. Just take the bolts off and move it off. You don't even have to take the lines off. Just pull it out and look inside there with a flashlight. And if it's all wet, that means the brake master cylinder has a semi-internal leak. The other leak that it can have is an internal leak inside the system. So inside here, if the seals don't work, you could have a leak. And the way you check for that is you come over here and you sit in the driver's seat, and then you're going to apply the brakes, and you're just going to hold the pedal down and see if the pedal goes to the floor. If it goes to the floor slowly, then you have a leak. And you have to make sure all your brakes are installed before you do that. And once again, you want to make sure you always check your brake fluid condition. If there's any contamination in there, it will ruin the brake master cylinder. Only thing that goes in there is the brake fluid that is required for that master cylinder. And there are different types of brake fluids, so you have to make sure that you pick the right, or not pick, but know what the right one is. And it's usually on the cap. So this one here, if you read the cap, it'll tell you if it's .3 or .4 or whatever it's supposed to be. Okay, so our next part is number 3. Inspect hydraulic system brake lines, flexible hoses, and fittings for leaks and damage. Determine needed action. Pretty straightforward. It's pretty easy. So what we're going to do is check for leaks, visible leaks. Easy to do. If it's wet, it's leaking. We're going to check our fittings, make sure they're tight, they're secured. So if you look at this one, it has a little bracket right there. On that bracket secures the line from vibrating. If the line vibrates up against the frame or something else while you're going down the road, because you're bouncing down the road, it'll eventually wear a hole in that metal and it'll leak. So we have to make sure those lines are secured where they're supposed to be. These flexible lines, you want to make sure they're not bulging. So we're creating high pressure in here when we apply the brakes, and if it has like a split on the inside part of the rubber, it will make like a balloon and kind of bulge out a little bit. And then if it's bulging, it could burst and you could lose your brakes. So you want to make sure any bulging lines are replaced. And that's it for that one. Okay, our next one is on metering valves and proportioning valve. What we're looking at is if we're going to check that, if our rear brakes are leaking, our metering valve won't work properly because it can never build pressure in the back brakes to signal the front brakes to apply. So then what has to happen is your pedal will have to drop all the way down past the portion that applies the rear brakes to get to the front brakes to apply. And so your brake pedal has a lot of travel and it's really hard to stop. with a leak in the rear. Also, your proportioning valve, same thing. You basically can check that by, you'd have to get pressure pads, and basically what you do is you put a pressure pad, it's a sensor, it tells you how much is being applied to the front brakes, how much pressure, and then how much you can put it also back here and watch your wheel cylinder move. So as your wheel cylinder starts to move, or if it doesn't move, and how much pressure is being applied to the front before this gets pressure. So it's kind of a complicated setup. They're really expensive, nobody really does it, but you could do it if you needed to. And then load sensing valve is basically a proportioning valve, which is going to tell us the 70-30 split. But what they do is they put a little lever, they move the proportioning valve to the back of the vehicle, and there is a lever that will sense how high or how low the back of the vehicle is. And as that lever moves, when they load up the vehicle heavier and heavier, that level starts to change, and it changes the valve on how much it applies the rear brakes. And so if it's a heavy load, they'll put more application, more pressure to the rear brakes before they start applying it to the front brakes. So let's say it's a 70-30. Well, if it's heavy, it might be down to 60-40 or even 50-50, depending on how much weight's in the back. And that's a load sensing valve. And it's all determined on ride height, basically. One of the tests we have to do is to check your pressure differential valve, and so that is the one with the wire with the sensor on the master cylinder. So what the best way to do that, I find, is to bleed the brakes. So if you bleed the front brakes or the rear brakes, what happens is it doesn't sense that pressure differential between the two when you're applying the brakes, and that will turn the light on in the dash, your brake light, until that pressure differential goes away, until that problem goes away when the brake pedal pushes down. If the light doesn't come on when you're bleeding the brakes like that, you could have a wiring problem. So then you're going to disconnect this, and then you're going to either jumper it with a paper clip, or if it's a single wire, you ground it. You check it when it's off, you check the light to see if it comes on when it's off, and then you ground it and see if the light goes on or off. So it should go on one way and off the other way, so when you ground it, okay? And that's just if you don't have the light coming on when it's supposed to. Then you're just going to check the wiring. If that's the case, it doesn't come on when it's supposed to and the wiring is good, it's probably the sensor. That sensor will need to be replaced. Our next step is brake lining inspection. And so we have brake linings in the front and brake linings in the rear. And so what we're going to do is we're going to do an inspection. I got a couple tools for brake pads or disc brakes. There's this tool right here. And what this is a measuring tool to see how thick the brake pad is. We want to make sure, let me get a flashlight real quick, right here. We want to make sure that we don't measure the backing plate. So if you can see, let me get one of these, point at it for you. You can see right in here, this part here is a piece of metal, that thick thing right there. But this, between the rotor and there, is the brake material. So we want to measure that brake material right there in between the rotor and the backing plate, which is the metal right there. So right there in the middle. And so you're going to take your tool, and these are pretty thick. So you take your tool here, and you basically try to see if it fits in there. Let's see if I can get the light on that right. See if it fits in. That was a little too big. And then we'll do the next one. And that's still a little bit too big. And we'll try this one here. Next one down. And that one fits in. It's like right there. Okay, and we're just going to look at the size of that, and that is, it says 8 millimeters. So we have 8 millimeters left on that brake pad. You have to measure the outboard and the inboard on both sides. And so make sure you don't forget to do the inboard as well. Sometimes you can do the inboard on the open spot on the caliper. And those are the same in here. You can check that. And you do both sides. You want to do brakes when they get down to 3 millimeters. So anything at 3 millimeters, which is about about that thick right there or below, needs to be serviced or needs to be machined and replace rotors or whatever you need to do for brake pads. You got to do a brake job at 3 millimeters. On the back, it's a little bit different if you have drum brakes. And so what I use is the tool that you measure your tire depth with, your tread depth. So this is a tread depth tool right there. And you push this down like that, and that end sticks out. And what you do with the tire is basically you stick it in the groove right here on the tire, and you push it down, and then it tells you how many 30 seconds or millimeters. And so this one is 30 seconds, or the equivalent would be 4 millimeters. So you do the same thing, except now on brake shoes, they are glued on and sometimes they're riveted. And so if you can see right here, those little bumps, those are little like grooves in there. That is the rivets that are holding the brake material on. When you do your measurement, you cannot do your measurement from the material on this side because this is not as thick as what's left in here. The rivet is holding onto the material, so this is a thinner spot than it is how thick it is on the outside here. You have to measure inside those grooves right there. And so you do push your tool down, and then you put it in one of the grooves. You pick usually the thinnest one, whichever one is the thinnest. It looks like this one right there. Push that down like that, and I'm going to look at that, and that is at 2 millimeters. And rear brakes you want to do at 2 millimeters or below. They get a little bit, you can get those a little bit thinner than you can on the disc brakes. So 2 millimeters for the rear, 3 millimeters for the front. Okay, so our next one here is going to be how to test brake fluid. Normally on vehicles like cars, small vehicles like this, I just look at the color of the fluid. It's pretty dark. If you know the age of the fluid, you want to service this about every 2 years. You're going to use a brake flush machine. You can flush this all out. But on large equipment that has a large reservoir, or let's say you're out on a mine in the middle of Alaska or something like that, and you have to fly everything in, it's expensive, and you want to make sure everything lasts as long as possible. You're not just frivolously replacing fluids that don't need to be replaced. So then what you can do is you can actually do a test. You can do a pH test on it. This is the similar thing for you advanced students that have done this with the radiator. So basically this is a pH test. You take this and you dip that in there. You're going to see where you're at. They also have a test. I don't have one, but you can check for water in your level, in your fluid, to see what it is. And all you do is you dip that in, you let her soak in there into those colored bars right there. You can see that. And then you're going to take that bar, and each one has a place for it. So the first one here is that one on the first one on this side. The second one is for this one, and the third one is for that one. And so if we look at this, I need my glasses, but we're looking at a 0 for which one is that? Is that pH? I think that's pH. And then the next one is, oh wait, here we go. Sorry. Oh, that's nitrate, and then we're looking at percentage of glycol. This is not going to work, but this is actually for coolant. But basically they make these for brake fluid too. Okay, and so I got the wrong one. Sorry, but that's the idea right there. And you're going to take these and match these colors up on the board here. So this is the color matches there on the bottom one. This one matches the color on the top. This one matches the color on the top of that one. And that's your scale. Okay. I'll have to get some of these for brakes. They're hard to find. So, all right. So that wraps it up. That was number 7, and hopefully you guys enjoy the video. I know it was kind of long, but let's move on, and we'll try to get some more stuff done on brakes.